Let's talk about how to build effective agents. So recently, the team at Anthropic released this magnum opus of an article called Building Effective Agents. And it goes into everything you need to know about what agents are, how to build agentic systems, how LLMs and workflows and all this stuff fits together in building effective agents. And so rather than reinventing the wheel here, I'm just going to go through this article with you, and we're going to pick out the key points, and I'm going to help you understand this article on a deeper level such that you can understand agents, how to build them, and how to get started. So let's dive right into it. So essentially, this is the Anthropic team's the lessons that they've learned while building agents and how to build them more effectively. So this is targeted at a slightly more technical audience, but even if you're not technical, if you're not a developer, I think you're still going to want to know this information, because as AI gets better, developers are being replaced by people that understand that you can just ask AI to code for you, and then you can ask it to do error handling for you. So with that being said, even if you're not a developer, stay tuned. So they define agent as a fully autonomous system that operates independently over extended periods using various tools to accomplish complex tasks. So let me read this again. A fully autonomous system that operates independently over extended periods of time using various tools to accomplish complex tasks. So this is the key difference between, AI chatbots or ChatGPT and agents, is that they are autonomous. You don't need to constantly be managing them. They're operating by themselves. Again, you don't need to be managing them. They're autonomous. They're doing tasks by themselves, and they're learning. They're using various tools to accomplish those tasks. So they're not confined to the environment of ChatGPT or Claude. They are given access to tools to accomplish tasks. And so think about this. What does every single knowledge worker do in this world? They click buttons using various tools. And so the idea is that an agent is a fully autonomous system that can replace a knowledge worker once it gets good enough. And so with that being said, the rest of this article is about how to use them, when to use them, how to build them, and what you need to know. So they call these agentic systems, but they say agentic systems are made up of workflows and agents. So workflows are systems where LLMs and tools are orchestrated through predefined code paths, and agents are LLMs that dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So this is the key difference, right? So if you look at kind of like the AI space these days, the vast majority of people that you're going to find, they are teaching you how to build AI automation systems. The whole AAA business model, Liam Otley, all those guys, how to build AI automation systems. What they're teaching you how to do is how to build workflows. They're saying use make.com or N8N or Zapier. I build these too. I think they're extremely valuable, but they're not agents. So I want to make sure that we get this right. An AI automation is a workflow. It's where you're adding in an LLM, you're adding in GPT or Claude or something into a predefined code path. That's the key terms right here. Predefined code path. You're defining what the trigger is. You're defining every single step of the way what happens to the data and how it gets input into the LLM. For many tasks, you might not even need agents, right? You might just be fine with workflows. But for a slightly more complex task, and this is why we're on like the verge of a massive paradigm shift in how we work online, is because we're on the verge of agents becoming extremely accessible to the vast population. Right now, they're accessible to people who are developers who understand how to build them using things like LangChain and N8N and all this stuff, which I teach in this channel. But what you need to know is that an agent is similar to a workflow in that it accomplishes and automates similar types of tasks, but it doesn't require that you build it out in predefined paths. You give it access to these tools. You give it processes that you want it to do, and then it kind of just figures it out on itself. It figures out how to do those things by itself. And so with that being said, let's dive into the next section here. And so we're going to get into a couple different AI agent frameworks, but let's dive into the little intro here. So when building out applications, you want to find the simplest solution possible. And so, okay, this is something I've noticed as well. Sometimes people build extremely complex systems that don't need to be complex, right? So when we talk about the difference between agents and workflows, what you need to know is that agents aren't always necessary because agents have a higher capacity for error. They're going to break more often as of right now, 2025. They're going to break more often. And what that means is that if you can create a workflow that is extremely predefined and reduce the amount of times that it errors out, that might actually be, there are many, many contexts in which you want to build workflows and not agents. And so keep this in mind. Like, if a simpler solution will solve the problem, why create an agent, increase the complexity and increase the headache that you'll have? So like they said, this might mean not building agentic systems at all. They often trade latency and cost for better task performance, and you should consider this trade-off. When more complexity is warranted, workflows offer predictability, whereas agents are the better option when flexibility and model-driven decision-making are needed. And so if you need to, if you don't want to build a workflow for every single possible decision that could be made, this is when you're going to build an agent. So for many applications, however, optimizing single LLM calls with retrieval and in-text examples is usually enough. So when and how to use frameworks. So this is these are the core frameworks of how to build agents. So there's Amazon, there's LangChain and LangGraph. Let me find where I was at. There's a drag and drop LLM workflow builder, Rivet. And so what it's basically saying here is that when you build out these frameworks, there's a couple core, this is what I'm excited to get into. There's a couple core strategies and ways of building agents that if you understand how to do them, you'll understand the vast majority of what you need to know about building agents. There's a couple different chaining calls. There's a couple different ways that you define and parse. And so you don't want to make this, again, do not make this too complex. And so, again, LLM APIs. What does that mean? It's whenever we go inside of like make.com or something, and we put in a ChatGPT or a Claude module. Let me log in here. I want to show you, I want to kind of like walk you through what each of these things are as they're being explained in this article. So we're going to look at the LLM APIs. This is a lot simpler than you think. If you ever use make.com, if you ever use Zapier, if you ever use N8N, you will understand what an LLM API is. I have videos on, Zapier, Make, and ChatGPT and N8N for how to create API calls. But essentially, if you're using the Claude module or the ChatGPT module, this is an LLM API call. So if I'm saying like message and create a completion prompt, for example, and I'm connecting my OpenAI account, putting in some credits, and then I'm choosing a model, maybe I choose O1. This in and of itself, this is an LLM API call. So they're literally saying like you don't have to be a developer for this. Start by practicing with prompting these LLM APIs. And then once you do that, then understand what are the workflows and the agents and all this stuff that you can build. But this is the fundamental core building block of agents, is API calls to LLMs. And so with that being said, the slightly more advanced next step is understanding what are those workflows, what are the different ways that we can build out these augmented LLMs and increase the complexity of these agents. So like they say here, the basic building block of an agentic system is an LLM enhanced with augmentation such as retrieval, tools, and memory. Our current models can actively use these capabilities, generating their own search queries, selecting appropriate tools, and determining what information to retain. And so if you think about an N8N agent, if you understand or have watched any of my videos on how to build agents in N8N, this is what we're doing. We're building the augmented LLM. And again, this is like the simplest aspect of an agent. So a certain amount of information goes in, it hits this agent. The agent then either does some RAG and does retrieval augmented generation. It gets results from some sort of vector database. It uses different tools and it changes the memory. So let's go into N8N here and actually like look at this a little bit. So if we go here into N8N, what you need to know is that inside of N8N, 1 second. We can build out this system inside of N8N. It's very simple actually. So if we go to the workflow, if we go to a new workflow, we start with a chat module. So we're going to start with a chat module. Okay, test the chat. And then the next one is we're going to build advanced AI, an AI agent. And now you can see inside of N8N, this is exactly what is talked about here in this article. You have something that's going in, you have an LLM that is able to do retrieval, use tools, and use memory. And what do you say? It's able to use tools, have memory, and do retrieval, right? And so at the end of the day, you're going to connect it to some sort of model. That's the AI agent part of it. You're going to give it memory, which is a vector database. So whatever the, this is inside of N8N, but whatever the vector database is, then you're going to connect it to workflows or tools. And so specifically each agent that you have is going to be connected to individual workflows and tools. So maybe you just want to give it access to Gmail. You want to give it access to Gmail, be able to like send and reply and do things to emails for you, or maybe you want to call a workflow. And so this is one of the most interesting ones. You can give it slightly more complex. So like inside of make.com, you can think of this as a workflow, right? Let me find some sort of workflow here that I built. So like maybe you want to see like my YouTube workflow, right? Oh wait, that's actually not my workflow. YouTube workflow. This is actually my Google Drive. All right, so this is like me creating an SOP using a Loom video, right? So here's a workflow. What we could do is we could hook this workflow. It would be built in N8N, not Make, but we could hook a workflow like this up to the agent. And then if we say like, hey, create me an SOP, it would figure out, okay, what is the input parameter that we want into this workflow? And how do I get it? And how do I trigger this workflow? And so you could have like 10 different workflows attached to one agent. It would give it a lot more capacity to do different things. So that is the basis of building augmented LLMs. Now with that being said, let's go into a slightly more advanced version. Prompt chaining. So one of the things that you need to know about building effective agents is that prompting is of the utmost importance. I cannot state this enough. I've already stated this probably hundreds of times on this channel already, but do not underestimate the importance of prompting. Most people get really excited with all these systems and these agents, and they try to go into N8N, and they try to like start building out all these agents, but their prompting sucks, and so the agents don't work as they want. So with that being said, getting really good at prompt engineering and prompt chaining, which I have courses on in my in the school community. Inside of the school community, there's prompt engineering and prompt chaining systems, as well as AI agent videos. But what you need to know is you need to know how to prompt these things. So let's dive into exactly what they've written in this article a little bit. This workflow is ideal for situations where the task can be easily and cleanly decomposed into fixed subtasks. The main goal is to trade off latency for higher accuracy by making each LLM call an easier task. Examples when prompt chaining is useful: generating marketing copy, then translating it into a language; writing an outline of a document, checking that outline meets certain criteria, then writing the document based on that outline. And so what you need to know is, in the current state of affairs in early spring, winter 2025, LLMs are good, but they're not that good. So LLMs can do tasks extremely well, but it can't do multiple tasks at once extremely well. So with that being said, what you need to be able to do is you need to be able to say, if I want, like this example, if I want to write a really solid document based on specific criteria, what should I do? Well, I should have the first LLM API call write me an outline. I should have the second one be a classifier that classifies whether it's good or not. And if it's not good, it tries to rewrite it. And then if it does meet a certain classification, like it meets certain criteria and parameters, then it will take that original outline and it will write the document based on it. So inside of N8N or inside of make.com, this is really simple to build out. So let's say we're going here, we're going to start a new scenario. It's basically like this. Let's build this out real quick. So let's say we have like a Claude module. We're going to create a prompt. We're going to do 4080. Let's just do a really simple one. So let's do literally exactly what they say. Write me an outline to a brand strategy document for the AI agent niche on YouTube. All right, so I'm having it write me a brand strategy document. If I run this module, it's going to create me a brand strategy document. Gonna wait for this. It's running the LLM API call like we talked about. Okay, boom. And now we can see the content of it right here. This is the document. And now we can do the classification. So the next one would be a classification. I actually like OpenAI, so you can switch the model up. You don't have to use the same exact model. And so we're gonna let it classify something. So let's say I do like 4.0 or 0.1 and I have it classify this outline. And so it's gonna be a little bit hard to do this simply, but let's just say we use GPT 4.0 system prompt. And we want it to classify whether this, well, let's see, what are the criteria we want it to classify it by. So let's say user classify this brand strategy document. So we're going to have it classify this brand strategy document. What that's going to look like is classify this brand strategy document as, what are different things we could say, as comprehensive or not comprehensive, as finished or unfinished, as, if we looked at this output, what are different ways we could classify this? Sufficient. Let's just say comprehensive or non-comprehensive brand strategy. We would then chain this, and how you chain a prompt is you use the output from one as the input into the other. Excuse me. So this is the brand strategy, and then we'll do a user, and then we'll do a system prompt. And so the system prompt might be, or the assistant system prompt might be example response. So we're going to do the classification as like JSON. So we're going to do something like classification comprehensive. And formatting guidelines, we're going to say output your response as JSON. I think there's a way to do that directly inside of here. Response format JSON. Okay, so now let's run this and see how it classifies it. Now that we give it an example, we get a brand strategy, and then what we're going to essentially do after that, once it's classified, then we're going to create a filter. So it's going to classify it. The result is going to be comprehensive. Boom. So now what we're going to do, this is what a chain prompt would look like. We're going to create a router, and then we're going to create a filter. If the classification is equal to comprehensive, then do this one. If the classification is equal to non-comprehensive, then do this one. And then we're going to say, let's say it's comprehensive. Then what we're going to do is create a prompt, and then we're going to say 3 opus 4080. We're going to say it says complete this brand strategy document. Write a 500-word brand strategy document using the following brand strategy and for the niche of AI agents on YouTube. And imagine like brand strategy outline. It's going to be the first one. And then I don't know what this one would be like. If it's not comprehensive, then I think we can actually start a workflow scenario. What we could do is run this scenario again, like just repeat it or break. This would be integration, Anthropic, Claude. So let's say like this is what we want to do. We basically have it iterate over this scenario. If it completes, it just runs the scenario again if it's not comprehensive. And once it is comprehensive, it does this, and then maybe it puts an output somewhere like a new Google Doc. Create a document. Inside of that document, the name is new brand strategy, and then the content is this one. And then maybe like once we finish that, I don't really care where it goes. Emails, let's just do it in a base one. And then what you could say, like you can imagine what types of things we could do here, where it's like if someone responds to my email campaign and they say, hey, and in the campaign I say, let me know if you want a brand strategy document. As soon as they want the brand strategy document, I create this scenario and it creates that brand strategy document for them, and then it attaches the document via an email, right? So it could be something like this, and I find the link. We're getting a little bit off topic here, but web view link. So you can imagine how good this would be. Ethan W. No, Ethan as smart scalingai.com. New brand strategy document. Okay, let's say we run this. Oh wait, it's gonna be an infinite loop. Okay, so we can put a filter there, which just like breaks or has like an error. But for now, let's just check what will happen if we run this. So ideally, it will classify this, and it will only continue if it classifies it as comprehensive. So boom, classified it as comprehensive. So this was successful. Then it's going to create a brand strategy document, and it's going to, once it finishes that, it's going to send that document to me. So it's going to be, this is what we mean by prompt chaining. You see we have 3 prompts in a row, and the output of one prompt is always the input into the next prompt. So once this finishes, it's going to create a Google Doc, which we're going to check out in a second. And this is essentially what we're doing. We have this LLM call 1, the output. It's either going to pass or fail. I guess this is just the exit. So this would be like just a fail. We would just have an error here. Boom. If it passes, it does another LLM call. And then we could even add a third LLM call here. And so, boom, let me go into the web view link. Let's see what it did. This is the output of our prompt chain. Boom, AI Agents Unveiled is a YouTube channel dedicated to exploring this, target audience this. You can see how freaking solid this is. Market analysis, content strategy. And people out here are just asking ChatGPT to create a brand strategy when you could literally just augment this at scale. And then it probably sent an email. I could probably check my email and I would have got a new brand strategy document in my email. So that is the essence of prompt chaining, which is a workflow that we can build. So imagine what would happen if you had an AI agent like this in N8N. Then one of these workflows that you called is something like this built out in N8N, not Make, but it has a prompt chain. Imagine how many different things you could have this agent do. So now let's talk about the parallelization and the routing flow. So we talked about what prompt chaining is, how to build those into your AI agent workflows, and now we're going to talk about routing. And so one of the important things, just to go a little bit ahead here, is that these are different workflows that you can build into your agent, but the actual agent itself is a different mechanism, right? So you can see like these, an agent is something that can act on its own, and use these workflows and building blocks. These are parts of the agent. These are things that you build into the agent, not the agent itself. With that being said, let's go into the parallelization flow. And so what this is going to look like is this. So let's say you want to build this out in N8N. Let me actually open it up over here. All right, so let's say we're going to build out a parallelization flow. What this is going to look like is essentially this. We're going to run a bunch of different, so let's say we have, we're going to trigger it manually. We're going to have like a Claude module, blah, blah, blah. So what a parallelization, why did it do that? I just want it's not the type of Claude module I want. Not a chat. Where is it? Let's use OpenAI for, all right, this should work better. So let's say we want to message a model. All right, so we're just messaging a model like this, right? When we're doing parallelization, the difference between this and prompt chaining is for this one, let me just duplicate this. For this one, it's the same idea in that we're having multiple different AI nodes connected here. But the difference is that, let's say we want to create some sort of variable here. Let's say, I think we can edit a field. Anyway, I'm trying to set a variable. It's a little different than make.com. I haven't created the variables in here yet. But let's just say we had like a Google Doc or something. Create a document. So the idea here is that, let's say we had the same example as before. We have, create, we want to create an outline for something. So this one creates the outline, or we want to create like a full in-depth brand strategy document or something like that. So maybe this one we're saying like create an outline of a brand strategy document in the following format. And then it's like, step 1, step 2, step 3, blah, 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 blah. And then it creates us an outline. Or actually, no, this is not what I meant to do. So let's say we have the outline and we're going to say like create a brand strategy, marketing strategy for YouTube. And then maybe the second one is create a brand strategy for, create an SEO strategy for XYZ niche. And then the next one is, create a LinkedIn growth strategy for XYZ niche. So the difference here is that in this last one, in a parallelization, we're running these, but they're all separate, right? We're not using any variables we're not using the output of this as the input into this one. These are actually completely separate. So we're going to get one response from this. Maybe we have like a set of data that we're pulling in, like some sort of spreadsheet or something. We get an output from this, then we use that original data again for this flow, and then we use that original data again for this flow, and then we have 3 responses, and we just combine them together. And then when we're in Google Docs, we're taking all the outputs from the 3 modules, and we're just like kind of combining them together. We're like concatenating or appending each response to one another. And this is the difference here, is that we're just running the LLM calls on the original data and then aggregating it. Whereas on this one, we're passing the data from one to the next, and it's more of a chain. It's a chain because this output will determine the quality of output 1 will determine the quality of output 2 and output 3. So that's what I mean by that. The second thing to know is that is routing. And so routing is essentially one of the core aspects of an agent. So this actually does have to do with agentic architecture, even though it is a workflow. And so what this happens is that This is when we're using specific queries or parameters to make something happen. So you can think of it like we're basically, like, let's say we have like make.com, right? We're basically getting an output, and then depending on what that output is, we're figuring out which way to route it. And so if you've seen any of my other videos, you've seen me use routers in a million different ways. But it's like you're just trying to figure out what is the next step, right? Maybe you're doing something here, and what you're realizing is that you're using the flows here. So you're using a flow. So if this is equal to this, do that. If it's not equal to that, do something else. So you're routing based on the LLM response, right? So you have some sort of data, and depending like what the users, let's say it's like this one, rather than clicking test workflow, it's actually a chat. So if this was a chat, on chat message, you're going to route it. So this means that if we're gonna put a chat in, so it's like a customer service message, hey, I need help with my subscription plan, right? Maybe that's what the user inputs into this chat window. And then what happens is, if the chat input, maybe you run it through an AI module first. AI chat model, it's OpenAI. We could probably use a really simple one here, like 3.5 something turbo. And then what you're basically saying is, if this is characterized as, that's not what I meant to do. I meant to grab the OpenAI message model 3.5. Characterize this message as subscription or product. And then the message is the chat window. So I need to, where the heck did that go? Then I'm going to create a flow. I'm going to create so basically what I'm doing is I'm saying, creating these different ones. Alright, so what this means is we have something like this, and we're basically saying this is the connection. We're going to add this in here. I want to build this out for you so you can really visualize what we mean by this. Data, expression, JSON, chat input here, test step, content subscription. Okay, and then if the output of this, if content is equal to subscription, do this, else if content is equal to wait, can we actually okay, so the idea basically is, let's just run this. Hey, I need help with my subscription plan. Boom. So what that should do is, let's do something like, let's just use another OpenAI module. So basically what we're seeing here is, and this is checking if content is equal to subscription. When content is equal to subscription, boom. Why did it not? The resources has been deprecated. So let me find a different model here. Is that going to work? So there we go. So if we say, hey, can I get help with my subscription plan? This is essentially routing the response. This is what it means to have a router. You have the AI module based on whatever the input is. It's going to determine if it wants to go, if the answer is subscription, do this. If the answer is not subscription, so my product isn't working, should go down this path, right? And then we have this path, and we're basically saying if content is equal to product, then maybe we give a chat response and we say, hey, I can help you with your product. And so that's the essence of routing. Now going into Orchestrator-worker. So an Orchestrator-worker, as it says here, it breaks down tasks, delegates them to worker LLMs, and synthesizes their results. So this is kind of what we talked about in one of the last episodes that we did. So let me pull up this Figma board for us. So inside of this Figma board, you can see that that's kind of like the AI agent architecture model, right? When we're going into AI agent architecture, we can see that there's worker agents, right? There's task agents. So if we go to this, we can kind of see what this looks like. You have the orchestrator agent, and then what it's able to do is figure out like what are the specific tasks that needs to happen. Can I break it up into specific agents that then do individual tasks that are associated with that agent? So that's what that means. And so now going on to the next one, the Evaluator-optimizer. So this, as it says, is one LLM call generates a response while another provides evaluation and feedback in a loop. And so I always like seeing what the examples are of this. So literary translation, where there are nuances that the translator might not capture initially, but where an evaluator LLM can provide useful critiques. Complex search tasks that require multiple rounds of searching and analysis to gather comprehensive information, where the evaluator decides whether further searches are warranted. And so evaluation criteria: when iterative refinement provides measurable value, the two signs of good fit are, first, that the LLM responses can be demonstrably approved when a human articulates their feedback, and second, can provide such feedback. So this is essentially how LLMs have gotten better over time. There's like literally human workers. It's going this, and then the human gives it feedback, and then it just keeps getting better and better and better and better. And this is what the Evaluator-optimizer loop is. And so when you're thinking about building agents, what you want to think about is integrating one of these Evaluator-optimizer loops into the agent build when you get started. Because if you do that, then you're basically essentially going to be able to improve the quality of the agent. Like this is like the training period. So maybe you build the agent and you want it to get better. You implement this workflow into your agent for like a week or two, and you have someone like kind of training it, or you are training it based on the responses, and then within a couple of weeks, the LLM is a lot better and it understands your workflows much better. And so going on to the actual agents part, and so agents, like we said, understand complex input, engage in reasoning and planning, use tools to solve problems, recover from errors. This is the recovery from error part, if you're interested. So agents begin their work with either a command from or interactive discussion with the human user. So this is where the chat aspect of it comes in. Once the task is clear, agents plan and operate independently, potentially returning to the human for further information or judgment. During execution, it's crucial for the agents to gain ground truth from the environment, such as tool call results or code execution. To assess its progress, agents can then pause for human feedback at checkpoints or when encountering blockers. The task often terminates upon completion, which is also common to include stopping conditions such as maximum number of iterations. Can handle sophisticated tasks, but their implementation is often straightforward. They're just LLMs using tools based on environmental feedback in a loop. So this is key. They're typically just LLMs using tools based on environmental feedback in a loop. It is crucial to design tool sets and documentation clearly and thoughtfully. So you can see that the human, this is the chat component. So let's say we're going to build out an agent again. So if we want to build out an agent, we're going to have the initial chat feature. So we have the chat trigger, and then we have the agent. Yeah, agent. We're giving it specific information. And this human, this is why we always start with the chat. This could be, this could be Telegram, this could be WhatsApp, this could be SMS. You can connect this to any form of chat feature. It doesn't necessarily have to be a chat. You don't have to operate this within any end. You could just connect it to, WhatsApp or Telegram or something, and then you're just asking it to do certain things within your Telegram or WhatsApp, and it's actually just performing these actions, right? And so then the LLM call, the action, the environment, and the feedback. So we can think of it like this. We can build in that workflow optimizer loop or evaluator optimizer loop inside of one of these agents. But how you think about it is, here's all the different tools we're going to give it. Maybe it's a workflow, maybe it's code, something like that. And then it needs to go, this is the environment, right? So if we give it like all of the potential things that it could do inside of Gmail, like it could send a message, it could, mark as read, it could mark as unread, it could do any of these potential things to a message. And this is like the environment. And then based on the responses that it's getting from these emails, based on the memory and the vector databases that we're adding into this model, and based on other things as well, this is getting feedback from the environment. And so it's not like the window memory and the tools are what is giving the feedback, and then we can also jump in there and add manual feedback as well. And so as we're seeing, agents basically enable people to use AI to solve increasingly complex problems that require the AI to make decisions. So the agent's autonomy makes them ideal for scaling tasks and environments. The autonomous nature of agents means higher costs and the potential for compounding errors. We recommend extensive testing in sandbox environments only with the appropriate guardrails. The reason that they put this in here is because imagine you give an AI agent access to your entire computer. Like there's like a Do browser or whatever these are that I've had videos on. The risk with that is that if you have saved passwords, if you have saved bank account, it could go off the rails, right? So a lot of times one of the best practices with this is always run it within a virtual machine. If you run it within a virtual machine like NST browser or Docker or something like that, this is putting it within guardrails so that it's not going to like take over your computer in a way that is actually harmful. So here's a couple examples. Coding agent to resolve SWE bench tasks, which involve edits to many files. Our computer use reference implementation, where Claude uses a computer to accomplish tasks. I believe this is the computer use demo. Yeah, this is the kind of I did a demo on this a couple months back as well on how to like computer use and Do browser are very similar. And so it's not about building the most sophisticated system, but the right system. Start with simple prompts, optimize them with evaluation, add multi-step agentic systems only when simpler solutions fall short. Maintain simplicity, prioritize carefully. This seems like it's written by AI. I wouldn't be surprised if it was. Prioritize transparency by showing the agent's planning steps. Craft your agent computer interface through tool documentation. And so in the last video, you kind of saw some of the use cases that we went through. But I'll just go over this really quick. One of the things that's really important with AI agent architecture is you have to use JSON liberally. Anytime you want to transfer data from one to another, try to like refine it so that like if you're using OpenAI to create JSON, make sure that that output is getting the right JSON 99 times out of 100. And really, play around with this. This is new stuff. We're on the frontier here. Any amount of work that you do inside of end-to-end, building out these agents, setting them up, setting up vector databases, so on and so forth, is going to be extremely valuable. And I highly recommend that you just get your hands dirty. And even if you break stuff, oh well, like you can't really do much harm inside of N8N. Just set up an agent, connect it to a vector database, connect it to a model, start giving it some tools, and just start learning how to build this stuff. So I hope you found this article valuable. This article, along with some additional training, is in the school community. We do live agent builds in here. And so if you're looking to just dive deeper into AI agent systems, this is going to be for you. And if you want to work with me one-on-one and get more of it done for you, white glove service, go to smartscalingai.com, and this is where this is the business, the agency in which I build custom solutions for people. And so I'd be stoked to have you in this community if you want to learn, do calls with us, etc. But other than that, I really appreciate you watching this far into the video. I'm going to be going really deep on AI agents this year in 2025. And so this is only the beginning. You can see it's January 16th when recording this. And so come the end of the year, we're going to do a lot of more videos on this. So thank you so much for watching, and I will see you in the next video.